Perfect. So now that it's completely memorized by everyone, we'll carry on. From the graph of the unit circle, we can get the graphs of sine and cosine. So you're going to want that picture in front of you. Actually, you already have it on top of that paper there. I'm going to do one at a time here. In fact, what we're going to do is we're going to do sine in class, and then I'm going to have you do cosine on your own. So if you need an extra sheet of paper, please go online to print it out. I think it's called Unit Circle Graph Paper on my website, on the Math 15 out of 10 page. What I suggest you do off to the side, because we have some decimals there, please figure out, well, I'll give you the hard one. 1/2 is 0.5. What's radical 2 over 2, and what's radical 3 over 2 as a decimal? So 0.7 for radical 2?
Radical 2 over 2 would be 0.9.
And this should be the 0.9, right?
Yeah.
0.85 approximately. Okay. We don't have to be that discrete about it, only because, I mean, notice this is 0, that's 1. So the difference between 0.86 and 0.9, we're not going to be able to tell that easily. Okay. So again, we're going to reference our unit circle a lot. Here is the deal. We're going to graph the function for sine. Since we are graphing the function for sine, looking at all those coordinates we have on our unit circle, which coordinate are we looking for? The y coordinate or the x coordinate? We're looking for the y. Okay, so on this graph here, the x-axis represents the angle, theta. The y-axis is going to represent sine. Okay, so let's look at the first angle measurement, which is 0 degrees or 0 radians. At 0 radians, what is the corresponding sine value? In other words, what's the y-coordinate at 0 radians? 0. So that's the point 0, 0. Okay. The next radian measurement is pi over 6. At pi over 6, what's the corresponding y-coordinate? 1/2. So notice it counts by pi over 12s. So at pi over 6, we're going to go up to 1/2. The next corresponding one is pi over 4. What's the y-coordinate at pi over 4? Square root 2 over 2 has a decimal value of 0.7, so that's why we needed the decimal. So at pi over 4, we're going to go up 0.7, eyeball it. That looks good. Next up, pi over 3 is 0.9. So up here somewhere. And pi over 2 is 1. Hooray! We keep going. So next up is 2 pi over 3, which as a decimal would be what? 0.9. Someone else, the next radian would be 0.7 at 3 pi over 4. Next up is 5 pi over 6, has a y-coordinate of louder vision, 1/2. And pi has a y-coordinate of 0. So if you were to connect these dots, you would get basically a hill. Now mine's a little off here. Oh my gosh. Let's see, can I rectify this somehow? That works. Do a little cosmetic surgery here. A tuck here, a lift there, very nice. Not nearly as many surgeries as Joan Rivers, but that's okay. Thank you. Okay. Now we're going to go the negative direction. Here's the deal. We learned about that magical term called toe curl. Yes. Good job, Mike. Co-terminal, which means two angles end up in the same place. So you keep going around. We're not going to get it because, like, for instance, the next angle after pi would be 7 pi over 6. Well, 7 pi over 6 is way over here. We don't want that. We want to go in the negative direction. So starting back at the x-axis, we're now going to move clockwise. So 11 pi over 6 is coterminal to what negative angle? Negative pi over 6. Yeah. So negative pi over 6 is coterminal to 11 pi over 6. And the sine value of of 11 pi over 6 is what? Negative 1/2. I'm sorry? Yeah. Good. The next one would be negative pi over 4, which is coterminal to 7 pi over 4. So negative pi over 4 is coterminal to 7 pi over 4. So the sine value at 7 pi over 4 is negative 0.7. Negative pi over 3 is coterminal to 4 pi over 3. The sine value at 4 pi over 3 is negative 0.9. And then negative pi over 2 is coterminal to 3 pi over 2. The sine value I think my hearing's going. Yeah, negative 1. Which one? Oh, so everyone's a critic now. Which one? Oh, 0.7, this guy here? Oh, okay. Yeah, it should be, I guess. My gosh. You never said you wanted the right answer. Thanks. Now we're going to go back up the ladder. So at negative 2 pi over 3, we should get negative 0.9. Negative 3 pi over 4, we should get the negative 0.7. Negative 5 pi over 6, we should get negative 1/2. And negative pi, we should get negative 1. Yes, because negative pi is coterminal to positive pi. I'm sorry, I didn't mean negative 1, I meant 0. I apologize. So, connect the dots. Hey, that was better that time. What's going to happen is this graph is going to keep oscillating. So it starts at the origin and just keeps oscillating in both directions. So even though we only graphed it up to, negative pi and positive pi, it goes on forever. What I want you to do is either on the same graph or on a different graph cosine for next week. You'll notice there is a relationship between sine and cosine, and as it will turn out, even though we have 6 trig functions, 2 of which are the same, are just reciprocals or ratios, you only need 1 trig function, and that rules them all. Dun, dun, dun. Dun, dun, dun.